So.
Okay. So welcome everyone. Today we're gonna talk about Python, kind of broader topic from basics to maybe advanced as well. So welcome Ron, he's our speaker today, and Ron has a broad range of technical disciplines. Ron has worked across really broad range of technical disciplines. So I have talked to Ron, and he has talked about compilers. He has talked about programming itself and decompiler and so many things. What I know about Ron, I cannot completely explain. So please, Ron, introduce yourself, and let's start then with you. I hope you are able to share your screen still, right?
Yeah, well, thank you for that introduction. I'm Ron Schreiner, and as was said, I've been blessed to have been able to participate in all sorts of different technological disciplines, probably way more than is even listed on the meetup page. I have recently got into quantum computing and quantum machine learning. And in the last couple of years, I've also done some teaching at a local community college. So that's basically about me. I'll go ahead and start the presentation. And we should be able to see the this thing over here. Make that, should be full screen now. How's that look?
Yes.
Okay. I finally figured out how to get Zoom to do that, right? Because I'm using multiple monitors. Okay. So again, I really want to thank our host for inviting me to come and do this and making this possible. And I've already mentioned that I've done some teaching of courses which I had to build myself. They were because they were community education courses, and when we get to the end, I am available for teaching or tutoring based, Python programming or Bash scripting. I'll talk about that a little bit more at the end. So we'll go ahead and get started with an eclectic slice of Python. I'll remind everybody that this is a presentation is not meant to be a tutorial on how to write Python code. I chose the title to reflect my personal experience navigating the various things in the Python universe. This slide deck is actually part of an intro to one of the CE courses for Python I taught. And it was basically an introduction where we gave out a whole bunch of interesting information and got the students to put their hands on some code and do some fun things. Let's see. So some of the things that we would cover here, did they go back? Yeah. That we will cover in this presentation are some of the, like, one thing we'll talk about resources in the Python world. Obviously there's python.org. There's so much stuff that's out there. Your main go-to place for Python documentation is listed there under python.org/docs. When you're starting a Python project, chances are somebody's already taken a crack at what you're trying to do. So there's odds are pretty good that there's a library out there that can help you out quite a bit. So one of the things I listed here is pypy.org, which is a place where Python libraries are stored, like in a community space. People can you can fetch all sorts of standard libraries from there, or non-standard libraries. People can share their, if somebody builds a library, they can upload it to PyPy and share it with the world. It's just like a nice clearinghouse catalog of code that's already been built. So a lot of times when you start a Python project, you might want to look up there to see if somebody's already done this. To get Python installed, you need to go there and look at the downloads and download what you need for your platform. Basically, from that site, you will get mostly the Python runtime. There might be other things that you load as you move along in your career with Python. Things like Anaconda, which gives you an environment manager. It's a nice place a nice tool that allows you to organize your projects and make sure they don't collide with each other. A lot of times when you're doing a project, whether it's Python or even any other language, you run into issues where you need certain versions of libraries, or you need certain versions of the runtime. You need everything nicely tuned, and you don't want to do that on your whole platform. What you want to do is keep all that tuning contained to a specific project. That's what Anaconda and some other tools like that will do for you. Another major thing that you'll run into as you get going is there's two major versions that are still out there in the wild, the 2.n and the 3.n. The 2.n is fading pretty rapidly because 3.n is really come on strong. A lot of different environments, like most Linux distributions, come with a Python runtime pre-installed right out of the box. You don't have to do anything, it's right there. There are some distributions that still ship an older version, like a 2.n, because some of their management code is still written against the 2.n. But if you're just starting up, I don't recommend you worry about it too much. You can start up, get the latest 3. Whatever that's available. But having said that, if you get involved in the Python world and as part of your career, you'll have to be aware of some differences, major differences between the two. One of the big ones is that in the 3.n world, all method calls or function calls have to be followed by parens. You can't leave the parens off anymore. Let me just do a basic language overview. Again, this is not intended to be how to program, although we'll show a few things here, but given this amount of time, we're just doing a very quick, like I said, an eclectic slice. So it's gonna cover a broad range of things, and in not only in scope but in complexity. Some things that I will mention about Python: it is object oriented. I would say that if you're familiar with object oriented, you might find that it's not quite as the object oriented model that Python uses you may not find it is quite robust as C++, but it is a very functional model, and you get a lot of work done with it. And the basic tenet of object-oriented is if you start your project using an object, odds are going to be a lot better for you that you'll build some code that's reusable, because in the beginning, when you start programming, you might write a collection of methods, or you might write one big program and not worry about methods. But the odds of you being able to reuse that code will be minimal. If you take a little bit of effort, start out with objects, I think you'll find that now that you have an object definition, you could import that into other projects. One thing about Python is it's typeless. Actually, this is a little bit dated. The newer versions of Python, even though it's still typeless, they have now mechanisms where you can add, I think they call it hints, where you can force type correctness. There's a lot of people out there in programming land who complain about typeless languages. Personally, I prefer typeless languages. Uh, Languages that require all this typing require a lot of extra typing, physical typing to get your code in there. It becomes more tedious. I prefer typeless. You know, it shouldn't be that difficult to figure out what the type of things are. And actually, Python has built-in tools to do that. And the only time you worry about that is when you're debugging anyways. So I think your code is much easier to read without the type hints. And that's, you know, basically my personal preference. Another issue about the language, which some people, you either love this or you hate it. I originally hated it. And this is the white spaces structure. After you spend any amount of time with Python, you'll realize that indentation matters. And if you're coming, especially if you're coming from another language, it may drive you nuts for a little bit, but it's not that hard to pick up. But I always had the attitudes like, I like to use my white space the way I want to use it. But in Python, you got to be very careful how you use it. A typical example is a for loop. In Python, there's no closing entity that closes the loop. The loop is closed when the white space change, when the indentation or the initial white space on the line changes. I've gotten used to that. You know, now it doesn't bother me as much, but again, it could cause you some problems, especially if you're coming from a different language. Another thing we'll go on to is one thing about Python, and this is something that is a bug or a pet peeve of mine, is it's full of multiple semantics. Some of the examples of this are there's different semantics or different syntax for normal statements. There's a whole different syntax and semantics for list comprehension. In statements that are flow controls where you have a relation expression, which like a true or false thing, it's a different set of rules govern those. For example, in the if statement, in the conditional part of an if statement, you can't put a statement. It has to be a relational expression.
Sorry to interrupt. I just wanted to make sure if we were supposed to be on the first slide, like has someone forgotten to flip, or is this the correct slide, Ron?
Which
The one
slide
you're
do you see?
showing.
Language overview?
An eclectic side of Python, the cover page.
Oh, it's not moving?
Is it for anyone else?
Thank you for pointing that out. How's that? You know, I
Now
think
I
that's
can.
an I think
I
that's
can
an
see
issue
movement on
with
your screen.
Zoom. It doesn't like that full page stuff.
Now we can see your screen and things happening. So
Okay. All right, let me just blow this up then. And then, yeah, thanks for pointing that out. So the slides weren't moving? Okay.
no, I thought you were just giving an overview, but then, you know, it didn't feel like that any longer.
Okay. All right, well, we can do it this way. So we're talking about multiple semantics. Was talking about the rel-op expression. There was a big war going on in the Python development community, the people who developed the language itself. In fact, the original creator of Python stepped away from his malevolent master in charge thing for a while over this particular issue. And it had to do with adding syntax to the rel-op expressions so that they were more C and C++ like, or allowing you to actually use a statement as a rel-op expression. And I've always wondered why they didn't do that from the beginning, but again, it caused a war. The gentleman stepped away and then came back. The thing that they came up with to do a workaround on that is a bit ugly, but so that little caveat is a little outdated. What else do we have? So we have also we have support for design patterns. Let me see if I can. There's support for design patterns, and some of the examples of that have to do with, there's this thing in Python called decorators, very powerful feature. One of the things I really do like about Python. The downside of decorators is every time you go to use them, you almost have to go back to the manual to figure out how they work, because they're a little bit complex, but it allows you to do some very powerful things like if you have a collection of methods or functions in your program, and all of a sudden late in the game you decide, oh my gosh, I need to log these things somehow. Well, you can build the logger as a decorator, and then you could just basically attach that to your functions. What this does is it'll turn your function into a logger without changing the function itself. So it's a very powerful feature. Some of the other design functions is recent versions of Python have introduced these things called contexts, which are very nice mechanisms for doing things like asynchronous operations, like opening a file and reading stuff into it. These new contexts really makes it nice, tight code, and the context concept is that context will handle all of the standard errors that you might run into. Typically, people would write code before they showed up, like to open a file, they would put it in a try exception loop, and it just, it became all this extra code that made your code look pretty junky. Now all you have to do is use the with directive, and basically you're adding 2 elements to your code, and the code that you originally wrote runs just fine, and now it automatically handles errors. It automatically handles closing the file if it was a file that you opened, or it was some sort of object that you instantiated in its context sensitive. It'll do its cleanup, and you don't have to put that in your code. It's just handled for you. Pretty cool feature. Some of the other things in the design patterns are the ability to do things like build object and function factories. And we'll probably talk a little bit more about that. Well, we'll talk about that a little bit more in the meta. One of the things that I have come to like about Python is it is open to doing what I call, or some people call, meta programming. And this is a technique where you write code that writes code, or you write code that creates code, or you write code that is more robust and is more sensitive to handling errors properly. So a lot of these things have to do with one thing I just mentioned was factories, the ability in Python to create object, method, function factories. And inside these factories, what you're doing is you're custom building let's say a function. Basically, when you call the factory, you can give it some parameters, and it'll hand you back a function that is custom built based on those parameters. Very powerful feature. Okay. So that's basically, again, a high-level overview. It's kind of an eclectic slice.
Yes, but the slide is still not moving. Like, is it just me, Kevin, David? Do you guys see other slides or just this one?
It moved?
Yeah, they move.
But I don't see any, like, there are just top. Okay.
So we should be on we should be on development environments now.
Yeah, it's just text. It's just text on the right. The text moves.
Okay. Awesome.
Yeah, okay. So another thing you'll run into, if you get involved with Python, is you're going to have to learn how to access or interact with development environments. There's a whole range of them available. Cool thing about Python is it's basically just text. You want to jump into a terminal and pick out your favorite text editor like Vim or, heaven forbid, Emacs. You can build Python codes, and I've actually done a lot of work with Python where I don't use an IDE. I just use an array of terminals and write code in one terminal, run it in another terminal, do the debugging in another terminal, keep a Python reference open as a web page, all on the same screen. For me, that works okay. For really large projects or projects where you need to collaborate with a whole bunch of people, you're probably going to need, they're probably going to be wanting you to use whatever IDE the entity has settled on. When it comes to IDEs, there's a big range of those too. Obviously, VS Code is a very popular one by Microsoft. That's a pretty monstrous IDE, and it handles pretty much any language that you can think of. But if it doesn't, supposedly you can build your own plugins for that entity to handle a language if you define one, define a language yourself. When I looked into that, it wasn't very straightforward at all. Another IDE that's popular, especially in open source land, it's called Genie. It's an IDE I used for a while. The nice thing about that is I was able to make my own plugin for Genie to understand the language that I wrote myself, built compilers for and whatnot. And in a matter of a few hours, I had Genie understanding what my language looked like and all sorts of things. For the purpose of teaching, I go to IDE called Thonny. And the reason, and we'll get into that a little bit on the next couple of slides, and we'll talk about that because there's more information there. But probably one of the really up and coming environments for writing code is things referred to as Jupyter notebooks. There's all kinds of flavors of these out there. I'm going to show you, drag on here. You guys are seeing this come on, this fly on?
Yes.
Okay. So this is actually a Jupyter notebook that was created by our host. She used this in one of her previous meetups. And all I'm doing here is pointing out that you have these different sections in here. You can put documentation in, you can put code in, it captures the execution. When you're done with this, you can save this entire thing as a file and send it off to a colleague. When they open it, they'll see exactly what you wrote, what your documentation is, and what your results were. Very, very cool. This is probably one of the reasons this has become very prevalent in the machine learning world, in data science world, definitely in the quantum computing world. It's the go-to editor in the IBM quantum experience. The thing I just showed you was from Google's Colab, which is great because if you have a Google account, you can just go there and use it, and it's going to save your work to your Google Drive, but you don't have to install anything. You can go there and play with things, and really without having to do too much setup at all. So those are some of the ones I covered. There's obviously a bunch more. So for everybody who's in the audience, if you feel like it, go ahead and type in into the chat whatever your favorite IDE is, whether it's Python or whether it's for something else. Okay, so we should be on to this preview. the next thing we'll look at a little bit is how you go about creating Python programming, Python programs. I'm going to show a little bit of how we used GUI projects from the very beginning for training. And I'll talk a little bit about that when we get there. You know, why I chose to go that route. But what we're gonna, so before we get there, I'm just gonna pick Thonny as the IDE, and we'll go over a few things, and you'll see how simple it is. I'll be skipping over these somewhat quickly. When I was using this to teach a class, we would actually get pretty in depth into what was going on with that IDE, and so some things you have to cover is how to get it started up. You know, what's inside of it. A couple of tips based on experience on how to get projects created, and this can be used in any IDE. But this is basically what it looks like on a Linux machine. You can see here it's got an area for you can open up where you can write code that's saved to a file. It also has an interactive Python place. Sometimes you'll hear this referred to as Iron Python or IPython. This is an interactive place where you can go in. You can test little snippets of code. Very, very cool feature. Over here on the right side, there will be stuff that pops up, especially when you're running the code. It's going to keep track of all your variables and give you a constant update as to what their values are. Very nice feature. And again, there's not a whole lot to this. This is basically the 3 windows. Although it does have features, it doesn't take long to get students up and running quickly with this. And it's nice also that when you go to install it, it brings along a Python kernel that works perfectly with this. May not be the most recent one, but it's close enough. And again, we're just using this IDE for educational purposes, just so people can see how to manage code, how to manage and organize projects. You probably won't use Thonny if you're out there in the real world and doing, you know, active live projects, because they're going to probably, again, whoever you're working for are probably going to want you to use the tools that they have, you know, system wide in their entity. So a number of the things that you also got to cover is, you know, sometimes you might need to configure this. Some of those things we go over. The configuration is always a lot easier with an instructor, obviously. And most of this, again, it's based on experience. What, you know, why you want to make these settings a certain way, and obviously we do it to make sure that the training class goes as smooth as possible. Again, it's nice to have an instructor around to help with those kinds of things. And you can see that even though this is a very lightweight IDE, as you'll see here, there's a little bit of meat to it. There's quite a few things, and when we were in the class, we would go through a lot of these menu items just to see what they would do. The critical things that you know, the must-haves are you need a way to run your code. There's ways to turn on debugging, so that if you've got a problem with your code, you can turn on the debugging. It has all the classical debugging techniques, but one that's really nice, again, over here in the assistant, your variables will pop up and you can see them change as your code runs. It's actually pretty cool.
So is there any reason why you use this and not more popular ones like Spyder and Jupyter for students?
I chose this one just because it's easy to install. It comes with everything you need. It's lightweight. It only takes, it didn't take very long to get the students up and running with it. You know, minimal configuration changes between Windows and Linux. This thing also runs on a Raspberry Pi, which was another consideration for one of my other courses. but it just allows the students to focus on the basic stuff. We don't spend a lot of time on learning how to use the IDE. We really don't. We go over it in the beginning, but that's just there so they know that the stuff is there. Most of the stuff we do during the course is just writing the code, running it, seeing what the results was. If I were to change something for a course, I would probably move them to Jupyter Notebooks rather than look at some other IDE, or jump up to like VS Code. Another real famous one, which is kind of dying, was Eclipse. It's a monster IDE that can do everything, including bake bread, apparently. But it's huge and it's complicated, steep learning curve, does every language there is. But again, for me to get a student up and going, and since we were doing this in a virtual setting back in COVID days, I just had to point them at something like, if you're on Windows, give them a URL, just download it from here. You got everything you need. Boom, you're done. So that was, part of my thinking. But again, you'll see that it has all the basics. It's not a completely minimal system. I mean, it's got the ability to debug, but more importantly, this IDE out of the box comes with the interactive shell turned on. Some of the other ones, you've got to figure out a way to make that happen. And during the teaching, we do a lot with the interactive shell, because a lot of the times you're just doing a one-liner. It's like, how do I make this one-liner work? And then when you get it, it's all there for you. And we'll talk a little bit more about that too. One of the things we did also touch on is, and again, this IDE makes it simple, is before we start, think about organizing your projects. I know I mentioned that earlier. And here we talk about it a little bit. It's like, the number one thing you can do is find a place for your projects to live. And then underneath those projects, every time you start a new one, create a subdirectory. This is just basic, like a pro tip learned from experience. So that whenever you're doing a project, all the code for that project is in one place, and it won't crash into anything else that you might be doing. And we talked, when we were doing this, we would talk a little bit about the differences of whether you're doing it on Linux or whether you're doing it on Windows, where you might park these projects. But doesn't matter where you park them. It's just a matter of using the same discipline to organize and manage them. And this is advice that works on any IDE, any language. But again, it's one of those nice to have an instructor to show you how to start things up nice and cleanly.
Got it.
And then this is the slides where we go through talking about, and again, show the differences here about, now you've got your project set up. Now you need to create some files. And so we do this one time at the beginning, and it is very fast. We had a Linux version and we had a Windows version, because it had people on both platforms. And the Windows version actually had a little thing that was a little bit different, because you had to be sensitive about what the file names were, and you may have to change the name from the default. But it's just basic stuff we covered there. And so now, although again, this presentation isn't intended to be a how to write Python code, there are some basics that every tutorial that's out there is going to start with. And so you got to start somewhere. So the simple stuff like variable assignment, a simple hello world program. And this is where I was talking about before. You can see down here where it's like you just wrote a program here, print. You just wrote message equals hello world, print message. That's working code, right? So then you can copy and paste this code up into your file and save it. So very nice way to develop code, especially You know, if you're just starting out with something and you don't have a great direction on where you're going, you have this ability to test simple snippets of code before you commit them to the file. This is a technique that I use all the time. I'm like, even if I'm using terminals, one of my terminals might just be an interactive Python session. You know, if I'm thinking about a piece of code, I can go put it in there. When I get it working right, then I can just cut and paste it into my file and save it. It's really nice that it's that this one little Thorny IDE puts those windows together for you, so you can do the same thing all in one window. Some of the things, another thing that's good for this presentation is Python is a really nice language when it comes to interrogatory and interactive help. And again, this is more powerful with the interactive Python, or as we see here in Thani, they called it the shell, but I guess it is a shell. It's a Python shell. One of the things, you know, in here, if you ever commit anything to Python, these three commands are the three of the things that you should commit to memory. Most things you don't have to commit to memory, you just need to know where to look them up. But you probably, as you move along, you probably learn how to use, you know, if you learn how to use these three commands, these methods over here, in an interactive session, you'd be very surprised at how powerful it is. You can see here that like previously we talked about how Python is not out of the box a typed language. Well, if you're trying to debug something, you can use the type function as it's shown in this this little clip here. You got a message, you can say, you can ask the message, what type are you? You get an interrogatory response. It's a string. Cool. Again, this is part of that object-oriented thing where you can interrogate an object and get information from it. The next one that we go on to is the directory. They abbreviate it dir. And again, here we already created a message. When we do a dir, message is an object. We already know that it's of type string from the previous one. Now that we know what type it is, we can do a dir, a directory function on it. It's going to give you a list of all the methods. These are all the things that a string knows how to do, or attributes that the string has. Some of these things are just data values. Some of these, a lot of these things are method. Typically, the double underbar, or they call it a double underbar, tend to be attributes. Those are just static variables. But these other ones that are down here, these are all methods that you can call on a string. So, for example, my hello world thing, I could do I could see in here that we've got we have a method called upper. So if I did a print message.upper, chances are it'll turn hello world into all uppercase, right? This is very, very handy. It allows you to, again, interrogate the object, and you can say, what do you know how, what do you know, what are you made of, and what do you know how to do? I know how to do upper, I know how to do zero filling. These are all powerful string functions. And you can do this recursively, which is also a very handy thing. I'll show that in a second. We'll go on to the next one, which is the help function. So once again, we created a string object called message, and when we call the help function on it, you get this little chunk of documentation that comes flying out of it. Nicely formatted, shows up on the screen. But it tells you, it gives you some documentation that's built into the object. I see here that it's, oh, this one I didn't do it until I ran it afterwards. But here, remember how when we did the dir message, well, one of those methods was called join. Well, you can ask for the help on join. So again, you can descend into the object and learn a lot about it without having to go anywhere. You're right in your interactive environment, and you can pull up this information just by remembering again those three directives. So the next thing that, again, this is part of the eclectic slice. We're going to talk a little bit about how some of the things you could do if you want to build a GUI, like a standalone application that's a graphical user interface. Now, just because, just like when I chose the Thani originally to be something that was simple, low learning curve, easy to use, easy to get, I wanted to use teaching examples that included a GUI. And the reason for that is I've always found writing code that just prints text, if you're trying to learn how to build a code and all you have is a printf as your output, that's really boring, and it's tedious, and it's not really very rewarding. So when I was doing this class, we jumped right into, once we got some of the basics on the way, we jumped right into, let's start doing a GUI thing. And the thing that I chose for the GUI framework was a thing called Turtle. Incredibly simple, allows you to do interactive drawing, allows you to, if you really get into it, you can build widgets. But mostly what it gives the student is a very nice interactive environment where as they're writing code, they're getting a visual feedback. In Turtle, Turtle is easy as making sure you have the thing in your local repository, and in most distributions of Python, it's already there. That was another reason for using it. And to access it, you just import it, just like you would any other resource in Python. So we start out with a simple program, draw a couple boxes. When you run this program, this GUI window pops up and it does whatever your program does. So you're going to get an immediate visual feedback on how your program is working. We also, at this point, we jump to, we're doing most of the programming as a collection of methods and saving that as a file, so we can access that at later points in the program. We go to, okay. Once, then we take it up a notch. We get into just making a little bit more, at this point we're adding more capabilities of the GUI framework, because now we have, we're changing the size and the color of the pen. We're also adding some new details to the Python language. To draw these boxes, obviously we didn't code each box. So I'm sure you all could imagine we were using this as a teaching opportunity to show how to use for loops or some sort of iterative process. So not only were they learning how to do visualization feedback, they're learning new features of the language. Again, we had some more as just what I talked about. We were adding some more capabilities of the GUI package, but now we also introduced the concept of lists. Notice how rather than hard code the color for a pen, we just made a list, and we wrote a little routine that basically round robin these colors. So as the program ran, every time it went to draw something, it would pick a different color from the list. Students had to learn a couple more features of Turtle. They have to learn how to use a for loop, how to iterate through it. And again, they get an instant visual feedback. At some point, when we get real comfortable with the GUI, we started to play with some a little bit higher level programming features. And one thing that we do, here's this is probably not gonna. This is gonna run right now. It pops up on the wrong screen. There's a screen that pops up. For some reason, it doesn't understand multiple monitors. We get into the fractal. I'm going to run this one. So again, we're learning this one. You can actually see it draw, right? So what are we doing here? We've introduced a couple more aspects of the library. We're introducing concepts of dynamic programming, which in this case of that last fractal I just showed you was recursion. Recursion is one of my favorite all-time thing to go to, but it drives a lot of people crazy. I know a lot of people that are terrified of it. But the nice thing about this recursion thing is it draws up your picture and you can tell immediately whether it's working right. You know, based on the visual feedback. Again, very powerful in a educational environment. And then the last thing that I'm going to touch on, I guess we get 10 minutes. Okay. Talked a little towards the end of the course, and the thing that I want to bring to this session is Python is everywhere. Again, if you are using a Linux distribution, it's probably pre-installed. If there's any people here that play with Raspberry Pis, these little tiny computers, the Linux image that you download for a Raspberry Pi is Python pre-installed. Actually, the Linux image that I was using, the Raspberry Pi OS Linux image I was using already had Thonny preloaded, which was another reason I didn't have to mess with it too much. So one of the last things we can talk about is using Python to run your do-it-yourself projects. You get a project where you embedded like a Raspberry Pi into it. You can connect the GPIO ports of the Raspberry Pi to the devices in your project. Use Python via the Thonny IDE and the GPIO library, and you can write programs that can run circuits. And like what this particular circuit was doing is we were just using two of the GPIO pins to drive a shift register. And what this was demonstrating is how you could build an LED display with just 2 wires coming out of the Raspberry Pi. And we go through the process of building the Python code based on the GPIO library. So at that point, now you've introduced even another library, and we've introduced techniques for interrogating that library and going out and learning about it. And what you wind up with is the ability to do you have a lot of power at your fingertips. And you know, we've done a very broad cross section of what's out there. And so what we try to do in that first class is to talk about the resources, the different versions. You know, we try to engage people in the communities that are out there. We show that it's everywhere. It's on Raspberry Pis, it's in quantum computing, it's in machine learning, like nobody's business. And if you're just starting out, there's one language to learn. You cannot go wrong with Python. So that's all I have. I'm going to wrap up. I want to thank everybody for attending. I think we might have a few minutes for questions. Again, I teach Python and Bash scripting. If anybody is interested in contacting me there, we can. You can contact me on LinkedIn. I'll go ahead and drop that in the chat. I'm going to go ahead and stop presenting. And where'd the chat go?
Thank you, Ron. Thank you for providing this comprehensive overview of Python programming language. I didn't know about all these IDs. While you were explaining, I Googled a lot. Thank you.
Well, I hope everybody got as much as that out of it. There's a lot more to Python, but I think if you want to get people excited about it, you can't bang them over the head for hours and hours on the basics. Like give them an overview of where they're going, what they're going to be able to accomplish, what disciplines it's going to get them into. And again, I really love this business of teaching the coding part when we get to that, using visual feedback. It was really amazing to see the students' responses to that. Now, one quick story about that. One of the young ladies that was in my class, when her first fractal rendered properly, the big curly Q one, I could literally hear her sigh. She was so pleased with herself because she's like, I did that. So it was very nice. So so if there's any questions, I don't know much. We have a couple minutes I'm happy to answer questions if I can.
Yeah, Sam is asking about your slide deck, and if you have any other web page or LinkedIn you have already shared here or not.
Yeah, I'll get a copy of this or a link to the slide deck to you, and you can post it.
Okay, sure, I'll do that.
Or anybody that asks you for it, please share it with them.
Yeah, okay.
I see Sam asked, he was asking about Thonny. Again, Thonny is a lightweight IDE. As I mentioned before, if you play with Raspberry Pis, it comes pre-installed. It's available for Linux. It's available for Windows. It's a simple, and the nice thing about it again is it's a simple. You download one thing and you got Thonny and you got a Python environment that comes with it. Again, it may not be the latest and greatest Python, but it'll be enough for you to get started to start playing with Python. So anybody else have any other questions? Guess, is it okay if they unmute and come on and talk?
This turtle part is also by default there, always?
Pardon?
Turtle, is it by default always there? I don't know.
In some distributions, it's part of the standard the standard Python library. In some cases, you do have to go out and by using pip, do a pip install on it. Pip is probably well, it depends if you're in the Anaconda environment, there might be other ways to do it. But you may have to install the turtle library. I found though, again, because Raspberry Pis are for like the DIY space, the do-it-yourself space, and Raspberry Pis in general were targeted at educational environments. I'm pretty sure the turtle was included in the Raspberry Pi OS image. But again, if you're on Windows or another platform, you may have to go out and use pip to install it.
Okay.
Yeah, Ron, I have a question as far as navigating a lot of the resources like PyPy. How do you go about that? Like, what are some of the tips? I know others, say, for instance, have open source algorithms, and this sounds maybe like, small pockets of code that you can use for your own program.
Well, if you just go to that site, I'm sure there's a search box. I'll give you an example of the one time I used it. I had to build a automated secure FTP agent, so that and to do secure FTP really fights you over automating the password, because they really don't want you to do that. But there is a Python library, and I'm going to blank on the name, but it's a security and encryption library that knows how to do SSH, knows how to do secure. It knows how to do secure copy sessions or in secure FTP sessions. And I just went to PyPy and I did a search for automating secure FTP. And about 3 or 4 of them popped up. I had to wade through a couple of them until I found the one that I could use. And what I mean by that is I had to find one that was compatible with the version of Python I had pre-installed on the target system. I didn't want to be at that point in time bothered with upgrading it. So, but I found a Python library that was very simple to go in, read the documentation, and it was very simple to set up a secure file transport protocol agent so that I could write programs that could say, go out to this site and get this file. And it was completely hands off. It uses mechanisms to encrypt the passwords, but it was completely automated. I also looked into finding a Python library for doing image collages. Like if you had a directory full of like a bunch of PNGs, bitmaps, and you wanted to take 50 of them and just slap them on a workspace, like somebody would be putting stickers on a suitcase or something. Well, and you want to do things like randomize the orientation or the rotation or the size of the image and stuff like that. Well, there's a pip image management library out there, and I forget the name of that too, but you can just go search for that under PyPy, or you just do a Google search and it'll probably get you over there. And then it's just a matter of getting in the documentation, see if it's going to be a good fit. And then if you do decide you want to take the step of loading it, just remember those 3 tools will help you a lot. And it's like, okay, the first thing I do is need to instantiate this top level object. Once you do that, you can talk to it. You can ask it questions. You can ask it for help. You can ask it, what methods do you know how to do? So it's a really nice path.
Yeah, I mean, as far as the success rate, if you do like Chat GPT on some things, it's not always the greatest. And I brought this up before, is that you have to ask it like the core question based on that, what's tried and true with that programming language. So I was figuring if something like PyPy, if it's just more, greater success rate, basically, of doing simple tasks that you don't know how to do right off the bat.
Yeah. Well, I mean, the internet's a great resource, but again, there's been many times where I would be like, do I really want to write this from scratch? Let's go do a search, see if there's a library. More often than not, there's a library. You might have to spend a little time learning. I also did this with I found a Python library that knows how to parse electronic medical files. And I was able to use that library. I had to fix a lot of it, but it's still way better than me starting from scratch, writing my own
That's what
parser.
I'm finding too.
Yeah, I had to fix some things, but in my normal job, I'm an expert at ANSI X12 for electronic medical claims processing. And so I found this library and I got it to do a lot, but I did have to fix some things in it, but that's okay. Once you get it downloaded, you can do whatever you want to it if it's open source, right? I'm still way ahead of the cube way ahead of the curve by not doing that parser from scratch. So any other questions?
Ron, for beginners starting to learn Python, what would you recommend? Which IDE? I started with Anaconda directly, so I don't think that's the best to start with.
Well, Anaconda is not, I think there's that entity might have an IDE, but Anaconda is more of an environment manager, is from my understanding. So like when you load Anaconda, you tell it things like build me a project, and and these are the things these are the resources the project needs, and then it'll create that environment, and then it'll have commands that will allow you to switch between the projects. And the nice thing about that, again, is if you get a project where you're writing something in Python and you're using a Python library, but you're using a specific, maybe one version older than current, and that's what you want to use, you can load that into the project and it won't contaminate the rest of your system. If you're telling me that the Anaconda people have an IDE, I have no problem believing that. I don't think I've ever looked at it though. But that's what I understand Anaconda is.
Yeah. Sam has a question.
The intro to Python is 3 2-hour sessions, and I'm not teaching it for that college anymore, but I have been asked to teach it independently. So if you want to contact me on LinkedIn, I'd be happy to tell you about that. And again, as far as teaching or tutoring, I do like one-on-one. The maximum size group I like is 4 people. It just seems to be the right mix. So if you can get 3 more friends to come, you can do it as a group and go from there.
Cool. So if we have no more questions, I don't see any other.
Yeah.
Thank you, Ron. Thank you very much. Thank you for your time and thank you for this detailed session. Thank you.
Thanks, Ron.
Yes, it was my
Thank
pleasure.
you.
And again, thank you for making this happen. I really appreciate
Thanks,
it.
Ron.
Thank you.
Thank you.
Enjoy your Friday.
And your weekends. Take care,
Yes,
everyone.
and weekends. Yes.
All right.
Bye.
Bye-bye.
Thank you very much, Ron. Bye, everyone.